Hello everyone, welcome to my channel. I'm David and today I'm going to talk about OWASP Top 10. So OWASP Top 10 is the top 10 most critical web application security risk, and it's a topic that everyone should know. So I'm gonna go to the OWASP website and then talk about the basics of OWASP Top 10 and go through each item one by one very briefly. So let's go. I'm currently at OWASP website. OWASP stands for Open Web Application Security Project. It's a non-profit organization dedicated to improving software security. As you can see, they have a lot of resources in their website, but OWASP Top 10 is their main content. OWASP Top 10 is basically the top 10 critical web application security risks. Since 2003, they have been updating this list every 3 or 4 years. The latest one came out in 2021. The list is prioritized based on CWEs and surveys, and you might be wondering what CWE is. CWE stands for Common Weakness Enumeration. It's a dictionary of weaknesses in computer software. You can search for CWE and CVE if you want to know more. So if I go into one of these items, I see the associated CWEs at the bottom of the page, and each item is scored based on statistics. The first 8 items were selected based on CWEs, but the last 2 items made it to the list based on surveys. So the purpose of OWASP Top 10 is to raise the awareness of common security risks so that developers and security professionals can mitigate those risks. And it's not meant to be a complete documentation for security verification. Now I'll go through each item in the list and explain them to you briefly by giving some examples. The first one is broken access control. It happens when the access controls are either missing or not implemented properly. For example, a non-admin user is able to access other people's personal information. There should be a permission check before allowing someone to access personal data. Another example, a non-admin user is able to access admin page. There should be admin role check in all admin pages. Cryptographic failure. This happens when sensitive data is not encrypted. Sensitive data here means personal or financial data. For example, you go to a bank website and the website allows you to access without TLS encryption. So in this case, the bank can enforce HTTPS access by enabling HSTS policy. Injection. This is a popular one. User input might contain SQL query or script and should be validated, filtered, or sanitized. Insecure design. Sometimes vulnerability can come from design flaw itself. For example, a movie theater website allows you to do group booking of up to 15 people before requiring payment. A hacker might use this feature to do group booking several times to reserve all the seats in the movie theater. Security misconfiguration. An application can be misconfigured and become vulnerable. For example, the system admin can leave default accounts and passwords unchanged. Or system admin can build the source code in debug mode and expose the stack traces and internal information. Vulnerable and outdated components. The components like third-party libraries, OS, web server, database can be vulnerable, unsupported, or out of date. Identification and authentication failures. An application can have vulnerabilities in authentication or session management. For example, it can allow users to enter weak or well-known passwords. Or it might fail to clear user session after a user logs out. Software and data integrity failures. This is regarding insecure CI/CD pipeline and auto-update functionality. Those features can update software without verifying integrity and introduce unauthorized access, malicious code, or system compromise. Security logging and monitoring failures. Logging and monitoring are activities that should be performed on a website frequently. Failure to do so leaves the site vulnerable to more severe, compromising activities. If the events that should be audited, like logins, failed logins, and other important activities are not logged, this can lead to a vulnerable application. Server-side request forgery. A server-side request forgery, or SSRF, can happen when a web application fetches a remote resource without validating the user-supplied URL. So when a user sends a request with a URL parameter, the URL parameter might contain the on-premise internal website URL that should be forbidden. Parameters like these should be validated and blocked. So that's it, guys. If you liked the video, please hit the like and subscribe button below, and I'll see you guys next time. Bye.